Welcome to the DIY Honda Garage channel. DTC P2182 indicates that the Engine Coolant Temperature ECT Sensor 2 is out of range. The ECT sensor measures the temperature of the engine coolant, which is crucial for the engine control module, ECM, to make proper fuel adjustments and control engine functions. In the Honda Fit, this sensor helps maintain optimal engine performance and efficiency. When this DTC is triggered, it often means the sensor is malfunctioning or there's an issue in the wiring associated with it. This can lead to poor engine performance, increased emissions, and potential engine overheating. Therefore, addressing this DTC promptly is essential for ensuring the vehicle operates correctly and efficiently. The ECT Sensor 2 plays a critical role in monitoring engine coolant temperature, directly influencing the vehicle's performance and efficiency. Located near the engine block, typically at the cylinder head, it works in tandem with the Powertrain Control Module, PCM, to provide essential temperature data. This information helps adjust fuel delivery and ignition timing, thereby optimizing combustion. If the sensor's readings are out of the expected parameter range, it may result in incorrect adjustments, potentially leading to suboptimal engine performance, overheating, or excessive fuel consumption. Thus, understanding the conditions under which P2182 is triggered is key to diagnosing the underlying issue. Several factors can lead to the activation of DTC P2182. A faulty ECT Sensor 2 is a primary cause. If the sensor fails, it may provide erroneous signals or no signal at all. Wiring issues, such as short circuits or broken connections in the wiring harness linked to the sensor, can also disrupt the normal function of the sensor and lead to faulty readings. Furthermore, a malfunctioning PCM can misinterpret sensor data or generate incorrect commands based on faulty input, ultimately causing the DTC to appear. Each potential cause should be thoroughly investigated as part of the diagnostics to accurately pinpoint the issue. When DTC P2182 is triggered, drivers may experience several symptoms reflecting engine performance degradation. One primary symptom is erratic engine performance, where the vehicle may hesitate, stutter, or struggle during acceleration due to incorrect fuel mixture adjustments. Additionally, increased emissions can result as the engine may not be operating under optimal conditions, leading to inefficient combustion and driving up exhaust emissions. Warning lights may also illuminate on the dashboard, alerting the driver of a system fault. Addressing these symptoms promptly ensures the vehicle remains in optimal operating condition and avoids further damage. In the first step of troubleshooting DTC P2182, the vehicle should be turned to the on position. This allows the Honda Diagnostic System, HDS, to communicate with the vehicle's onboard systems. After initiating the on mode, it's essential to check the parameter values displayed for ECT Sensor 2. This involves comparing the current signal to established thresholds. Specifically, the sensor should produce a value of less than 0.09 volts under fault conditions. If these current conditions indeed match the threshold defined, confirming the fault becomes the next logical step, indicating that the failure has been appropriately identified, and you can proceed to the next step in troubleshooting. The second troubleshooting step involves checking the ECT Sensor 2 reading once more under different threshold conditions. In this case, the goal is to determine if the signal reading exceeds 4.99 volts. If the current conditions match this threshold, it indicates that the error is reproducible, prompting further steps to assess the fault. If the voltage reading does not meet the expected thresholds, it may suggest an intermittent failure, causing the sensor to function correctly under certain conditions while failing under others. Thus, It's crucial to examine wire connections for poor conditions or loose terminals at both the ECT sensor and the PCM, ensuring that physical issues do not exacerbate the sensor malfunction. In the third step, begin by turning the vehicle off before proceeding with the disconnection of the ECT sensor 2 via its 2P connector. Once disconnected, turn the vehicle back to on mode to check the parameter readings again using the HDS. The intent is once more to assess the voltage from the ECT sensor 2. Under expected fault conditions, the voltage should return a reading of less than 0.09 volts. If the reading is confirmed, the troubleshooting proceeds to the next step, indicating a potential fault in the sensor itself, resulting in the need for replacement. If the conditions do not match, the sensor may be functioning correctly, requiring further investigation. This step starts with the vehicle turned off before jumping the short circuit switch SCS line with the Honda Diagnostic System HDS. This jump should be sustained for more than 1 minute to ensure effective testing. Following this, the PCM connector A51P should be disconnected to perform a continuity check. The assessment focuses on 2 test points: the ECT sensor 2 connector and body ground. By checking for continuity between these points, it helps identify whether a short circuit exists in the wire leading to the ECT sensor 2. If continuity is present, it confirms a short circuit along the TW2 sensor line, necessitating repairs on those lines. Step 5 follows the same protocol of turning the vehicle to off mode before disconnecting the ECT sensor 2 and using a jumper wire to connect the terminals A and B of the sensor's 2P connector. Replacing the sensor connection with a jumper wire enables a controlled test of the sensor's readout. With the vehicle turned back to on mode, the goal is to assess the ECT sensor 2's voltage through HDS. If the sensor reports a voltage reading greater than 4.99 volts, it suggests proper working conditions. However, if it doesn't meet this threshold, it necessitates replacement of the ECT sensor 2 as the root cause of the P2182 code. For this step, begin again with the vehicle off and remove the jumper wire placed in the previous step. This step is crucial as it resets the sensor circuit for accurate voltage measurement. Following this, turn the vehicle on and evaluate the voltage between test points again using the HDS, focusing on cohesion between the ECT sensor connector and body ground. Under normal conditions, the voltage should approach 5.0 volts. If this does not occur, further diagnostics will be necessary, as the issue may not solely reside within the sensor. Conducting analyses further will help track down whether it stems from wiring or the PCM, which might require more intricate troubleshooting. Step 7 dictates turning the vehicle to the off position before repeating the process of jumping the SCS line with the HDS for more than 1 minute. Upon completion of the jump, disconnect the PCM connector A51P to prepare for continuity testing. The focus will be on the SG5 line, checking continuity between the specific ports of the ECT sensor connector and the PCM connector. If continuity exists, it signifies that the SG5 line is operational, and further diagnostics concerning the DTC can incorporate the PCM for substitution testing. If continuity is absent, it indicates an open within that specific wire, requiring immediate repair to restore proper circuit function. In this conclusive step, turn the vehicle to the off position, followed by jumping the SCS line with the HDS for over a minute as before. Disconnect PCM connector A51P again to analyze the TW2 sensor line. This time, conduct a continuity test between the points specified within the ECT sensor and the PCM connector. If the continuity is confirmed, reaffirming that the TW2 sensor line remains intact. Next steps will focus on acquiring further service information for any related DTCs or issues. Conversely, if continuity is absent, it will demand repair work to fix any disruptions within the TW2 sensor wire to prevent the P2182 code from recurring. Final repair verification, post-troubleshooting, ensures that the ECT sensor 2 and all associated wiring function effectively. First, assess the operation of the repaired or replaced sensor to confirm readings are stable and accurate. Following this, inspect all wiring associated with ECT sensor 2 to verify that all connections are secure and no further issues exist. The next significant step is clearing the DTC from the onboard memory, allowing the vehicle's systems to refresh and recalibrate. After that, take the vehicle for a test drive to ensure parameters are returning within ideal thresholds, confirming successful resolution of DTC P2182. To prevent the recurrence of DTC P2182, regular maintenance is key. It is advisable to schedule routine checks of the ECT sensor to monitor its performance and functionality. During oil changes or other scheduled services, inspecting all wiring connected to the ECT sensor helps to identify any wear or looseness that could lead to future faults. Additionally, performing frequent scans of the vehicle's diagnostic systems may catch any pending or active DTCs early. Lastly, using OEM original equipment manufacturer parts for replacement ensures the quality and compatibility of sensor components, maintaining overall vehicle reliability. In conclusion, addressing DTC P2182 requires a clear understanding of the ECT sensor's crucial role in vehicle performance. Comprehensive diagnostics ensure that all potential causes are explored, from sensor faults to electrical system integrity. Accuracy in voltage readings and continuity checks is vital in isolating the issue appropriately. Regular maintenance practices play a significant role in longevity through periodic inspections and timely responses to warning signals. By fostering a proactive approach to vehicle care, both performance issues and sensor faults can largely be mitigated, ensuring the Honda Fit operates smoothly and efficiently. Please like and subscribe to the channel. See you next time!